All right, hi everybody. This is the IB Probability and Set Theory package. This is the section on conditional probability, and this is example 8. So in a group of 50 students, 40 study mathematics, 32 study physics, and each student studies at least one of these subjects. Now, the reason why that's important here is when we jump to our Venn diagram here, if each student studies at least one of them, that means there's nobody that sits outside those two sets here. And we know that there are 50 students in total in the universe. Okay, and this is going to be our, let's say this is our mathematics and this is our physics here. Now, we know based on what we're seeing here, or based on what we're told here, that 40 students study math, 32 students study physics. If we assumed there was no overlap between the two for right now, that would mean that the sum of the students in the mathematics circle here in this Venn diagram or this set plus the number of students in the physics set should add up to 50. So if we think of that, if we've got the math here plus the physics here, this should end up being the universe if the two sets have no overlap. Now when we look at that, that's 40 plus 32 gets us 72. That is way bigger than our actual universe here. So what that means is there's got to be overlap. Therefore, there is overlap. And to get that, we're going to take our 72 students that we found, and we're going to subtract from that our 50. Okay, the size of the actual universe here, because what's happening here is the overlap here, the amount that we're over the actual universe, this must correlate back to the doubling up here. So what that means is we're counting this group right here, we're counting this group, but we're counting this overlap in both. And so we're just going to figure out how much overlap there is there. And 72 minus 50 is 22. So what that means is we've got 22 students inside here. Now for mathematics, the whole mathematics circle is 40 students. So if we subtract the 22 there, we're going to be left with 18 in just the mathematics. And with physics, what are we told here? We're told there's supposed to be 32. And if we subtract the 22 from the center here, we're left with 10 students that study just physics. Okay? So, from a Venn diagram, find out how many students study both subjects here. Okay, well there you go. We've got 18 here in this section, 22 study both, and 10 study physics. Okay? Now, the question here, is how many study both subjects. That is the 22. Okay, I'm sorry, I misread that. I was anxious to go on to the next question, but let's do that. Let's move on now. If a student, from this group is randomly selected, find the probability that he or she studies mathematics but not physics. Okay, we'll take a quick look up here at the Venn diagram. Studies mathematics but not physics. Well, math is this circle. This part here represents the and physics. So I've only got 18 students here. So studies mathematics but not physics is going to be 18 out of 50. And we can cancel out a common 2 there at the very least. That's going to get us 9 out of 25. And there we go. Studies physics, given that he or she studies mathematics. Okay, so now what that means here is, given that they study mathematics, is we are only going to focus our attention on this part of the universe here. Okay, we're going to assume that whoever we found is inside this particular circle here, in which case there's 40 students here. So how many of them study physics? Well, 22 study physics out of that group of 40. So the probability that somebody studies physics, okay, given that they study mathematics, and this is the way you would write that, okay, that little line there, given that, is going to be, in this case, it's 22 out of 40, and divide out the common 2, and you're going to be left with 11 out of 20. And that's the probability that somebody studies physics, given that he or she studies mathematics.